This is question 2, relative velocity 2019A. A man walks with a constant speed of 4 kilometers an hour from west to east. So he's going along here, west to east. He's going in the positive I direction. We'll call him M for man, so the velocity of the man is 4I plus 0J. The wind appears, so the velocity of the wind relative to the man appears to come from a direction 50 degrees north, 50 degrees east, which is a very strange way to describe it, but north, so we have to go north first and then 50 degrees east, so the 50 is in here. So if I do my x and y axis, or my I and j axis, and I draw this line where the wind appears to come from, my 50 is in here and my 40 is in here. So this is our diagram. So the wind appears to the man to be going down this way, so this is negative, negative. So if we call the speed of the wind, what we call speed u normally, so we're going to have minus, I'll just write it out underneath, minus u. We can see here, here's my, I'm adjacent, my I is adjacent to 40 degrees, so u cos 40 in the I direction, we don't have any other information, and minus u sine 40 in the j direction for the velocity of the wind relative to the man. We also know that the velocity of the wind relative to the man, we are looking for the velocity of the wind here, the velocity of the wind is equal to the velocity of the wind minus the velocity of the man. So the velocity of the wind, what we're looking for, if we bring the velocity of man to the left, it's going to be the velocity of the wind relative to the man plus the velocity of the man. So the velocity of the wind becomes this u cos 40 and plus my 4. So we have minus u cos 40 plus 4 in the I direction, and we just have minus u sine 40 in the j direction for the velocity of the wind. So the other components that they give us here is a woman walking in the direction 40 degrees west, north 40 degrees west. So direction north 40 degrees west, so again similarly this direction, if we go north and 40 degrees west, the 40 is in here, so we're going to have a 50 in here. We set up our I and j consistently. So let's see this, she's going in this direction, which is negative, positive, and we'll put the 50 in instead of using the 40. I think it's better to do that way. In the first version of this video I did it the other way, and she's also walking at 4 kilometers an hour, and the wind appears to come from the north, so the wind is coming down in minus j. Okay, so we have her speed is 4, so the velocity, we call her G, we'll call her the girl. The velocity of the girl is going to be equal to minus 4 cos 50 in the I direction. It's adjacent here. We have my I and my j, and we have plus, and it's going to be 4 sine 50 in the j direction. The velocity of the wind relative to the girl in this case is just equal to minus, we don't know the speed, do we need to give it a variable? We can say minus v times j, we don't know how fast it's going, but we could just call it minus j. I think in this case we'll leave it as vj for now, vj thing. So the velocity of the wind is these two added together from up above, just don't forget your w's, so that's equal to minus 4 cos 50. See here, we can just focus on the u part to be able to solve this question. That should be an I there in the I direction, and plus 4 sine 50 minus v in the j direction. We do need to give it some sort of variable, we don't know what it is. So we have here minus u cos 40 plus 4 has to be equal to this guy, minus u cos 40 plus 4 is equal to minus 4 cos 50. So getting u on its own, we're going to have, let me just change it to positive first. So I'm going to go u cos 40 minus 4 is equal to 4 cos 50. So 4 cos 50 plus 4, bringing the 4 across, divided by the cos of 40, will give me my u. And that gives u to be 8.578. 8.578. What do we ask for here? The magnitude and direction. Okay, so we need to find the velocity of the wind and then get the magnitude and the direction. So I'll just come up here and change color so we can see the velocity of the wind. It's going to be equal to minus 8. What do we get? 8.578 cos 40 plus 4 in the I direction, and minus 8.578 sine 40 in the j direction. And this is going to give me the velocity of the wind. It's going to give me minus 2.5711. Probably 2.57 is enough in the I direction. And then it's going to give me minus 8.578 sine 40, 5.51 in the j direction. So the magnitude of the velocity of the wind is the square root of 2.57 squared plus 5.51 squared. So that works out to be, typing it into a calculator, 6.08. And we're dealing in kilometers, I think, here, are we? Kilometers an hour. So kmh, which is km over h, or kmh to the minus 1, whatever you prefer. And then the angle theta is equal to the inverse tan of the j component over the I component, 5.51 over 2.57. And typing this into a calculator, the inverse tan 5.51 is, rounds off to 64.99 degrees, we'll say 65 degrees. And this direction here, it's going down in this direction, so it's 65 degrees southwest in there. And this question was set up kind of describing the angles in a kind of slightly different way than we'd normally be used to doing it in class. So that's 25 in there, so theta would also be equal to 25 degrees. When we go south first, south 25 degrees west, but I prefer this 65 degrees southwest. So that's 2019 done a slightly different way than previously. You choose the method that you want to use.